Oh, sorry, it's recording. So I'm going to go ahead and do the next set of questions. Yep, I'm doing this all in one go. I started uploading the other video right now, so now I'm just going to go ahead and get this done for you guys. I'm probably going to be late to work, so you're welcome, guys, for sacrificing my integrity and punctuality. So, 111. Let f be a continuous function such that the integral from 3 to 5 of f of x dx is equal to negative 4. And from, of course, they always do this. They always get the higher number on the bottom of that of f of x is equal. I'm going to, maybe I'm just going to change this now. Let me change this now. I just erased it, so now I don't even know what it says anymore. Hold on. Let me change this to be the integral from 3 to 9 of f of x is equal to negative 5. That way now I can look at this nicer. All right, so what is the value of f of 9 to 5? 9 to 5, or 5 to 9. Well, the lowest number is 3, the highest number is 9. Okay, so I'm going to say, let me get organized here. So the integral from 3 to 9 of f of x dx, whatever, is equal to the integral from the mid value is 5. So from 3 to 5 of f of x plus the integral from 5 to 9 of f of x. Okay, so now I just turned this into an algebra problem. This I know is negative 5. This, do I know this one? Yeah, 3 to 5 is negative 4. And then this is what we're trying to find. So I'll just call it plus, I'll just call it S. No, that looks like a 5. I'll go with Z there. And then I'm going to add 4 to both sides, so I get negative 1. Okay. Good. Oh, shoot. Hold on. Sorry. All right. So now let's look at number 112. So the graph of a piecewise linear function g is above. Evaluate the integral of g prime of x. Okay, so if I look at this, the integral of a derivative, they're kind of the inverses of each other. So integral of a derivative is just the original function, and then evaluated from negative 2 to 0. So I'm going to plug in my upper bound, so it's g of 0 minus g of negative 2. And I have the graph of g, so g of 0 is 0, so that's 0, minus. And then g of negative 2 is 2, so minus 2, negative 2. Done. All right, not so bad, not so bad. So, all right, now with this one, oh my god, I already know you guys are going to screw this up. I don't know why all year you guys just don't understand the concept that if you have multiple terms on the top and only one term on the bottom, you can break up the fraction. So I'm going to rewrite. Why am I getting mad? I don't know why. It's 7:18 in the morning. So let's see. I can break this apart as like x over x plus 3 over x, which is the same thing as 1 plus 3 over x dx. And yeah, this is an easy integration. So the integral of antiderivative of 1 is x, and then the antiderivative of 3 over x. Hopefully you recognize that the integral of 1 over x is natural log of absolute value of x. But so this is like, basically the natural log of the absolute value of x because you have 1 over x, but that extra 3 means you put the 3 up front. Because that's like saying 3, not 1 over, whatever, you get the point. So then but we're not doing a plus c because we have bounds that we're evaluating this from. So from 1 to 4. And now I'm going to plug in 4 first. So 4 plus 3, natural log of 4. I didn't need the absolute values there, but whatever. Because 4 is a positive number already. Minus, if I plug in 1, it'll be 1 plus 3, natural log of 1. Natural log of 1 is 0. If I do 4 minus 1, that'll be 3 plus 3, natural log of 4. Why is that not an answer choice? Oh, D. There we go. I don't know why I wasn't writing. Okay, so let's see. Moving along. Oh shoot, hold on. I keep getting a text message. Sorry. Crap. How do I pause the recording? I can't pause the recording. Whatever. I'll just keep going. So let's just go on to the next one. So for 114, if f prime of x is equal to 6x squared minus 2x and f of 2 equals 4, then f of 1. Okay, so here we got to do the antiderivative. All right, so the antiderivative is going to give us our original function. So it's equal to the integral of 6x squared minus 2x dx. And then that's equal to... let's see, 6x cubed over 3, which is pretty much just 2x squared, minus 2x squared over 2, which is pretty much just x squared, plus c. Let me write that nicer. So f of x is equal to 2x cubed minus x squared plus c. So they gave us an initial condition to work with. So I'm going to plug in this in for x, and this is what it's all equal to. So I know that f of 2 is equal to... 2 times 2 cubed is 8 minus 2 squared is 4 plus c is equal to this whole thing is equal to what? 4. So then I'll have 16 minus 4 plus c is equal to 4. I'll add the 4, so that'll be 8 divided by 16 is wait, no, not divided by 16, minus 16. So it'll be 8 minus 16, so c is equal to negative 8. And then, so there's my original function. So f of x is equal to 2x cubed minus x squared minus 8. And then I'm going to plug in 1 into all of this. So that'll just be 2 minus 1 minus 8. Minus 9 plus 2 is, nope, minus 7. Okay. So 114 is A. Let's look at 115. Let f be a differentiable function. The graph of f prime, the derivative of f, is shown above. And consists of a semicircle and 3 line segments. If f of 2 equals 3, then what is the value of f of negative 4? So this is the one where here's that initial condition, and hopefully you guys remember that that formula. And I'm gonna just please tattoo this on your arm if you have to. F of x is equal to f of a. This is going to be like some kind of initial condition that they gave us, right? So it's like initial plus the integral, right? So plus the integral of from the lower bound a to our upper bound x of what we're trying to find of f prime of t dt. Right? I use t because you technically shouldn't use the same variable as x, but they will not count that against you if this were a freak response. Okay, so now I'm going to go ahead and set this up. So I know that f of x is equal to, I know that if I plugged in 2, right? That means that my lower bound is 2. So I'm just going to put that there for now. And then f of 2 we know is 3 plus the integral from 2 to x of f prime. I don't know why I'm like all the way down here, but whatever. I'm like, whatever. So f of t dt. So then what we want to try to find is f of negative 4. So f of negative 4 is equal to 3 plus, well, actually, I already recognize that if I put negative 4 there, I'm going to end up flipping that. So instead of putting the plus there, stop. Instead of putting the plus there, I'm going to change that already to a minus and then flip my bounds from negative 4 to 2. I'm just going to do that ahead of time. Okay, so now I need to know what is the integral from negative 4 to 2. Okay, so that's from negative 4 to 2, so I need to find these two areas pretty much. All right, so this one is a semicircle, 1/2 times pi times the radius r is 2, so 2 squared. And this is negative because it's underneath the curve. Please don't forget the negative. So then this will be negative. So that's 4 over 2 is 2 pi. So minus 2 pi. So this will be 3. Well, wait, I want to give myself space for the other problem. Actually, that's going to be an easy one. I'll just do it here. So 3 minus parentheses negative 2 pi plus, because this area is going to be above, 1/2 times a base of 2 times a height of 1 is just 1. So 2 pi plus 1, which is 3. If I distribute the negatives, it'll be 3 plus 2 pi minus 1. So that's equal to 2 plus 2 pi. Right? So that is 15 is A. Good. So for 116. Okay, this is one where you know that if you took the antiderivative, You can just, and if the inside is a simple linear function, like, just an x to the first power with a number in front of it, even if there's another constant next to it, you can just do 1 divided by the derivative of the inside, and then take your antiderivative of the sine, right? And if you don't believe me, you can do your u substitution. Du is equal to 4 dx, get dx with 1/4 du, and then you'll notice that 1/4 kind of goes outside of the integral when you do your u substitution, right? So, but again, the little shortcut is if this is a linear function, then you can just multiply by 1 over the u prime, right? And that'll pretty much just do it, give you that. I know I just did the whole u substitution for you, but whatever. I'm trying to show you guys some shortcuts because time is of the essence on these AP exams. So anyways, I know that the integral of sine is going to be some version of cosine, right, of whatever's on the inside. But now I have to think backwards. Especially when it comes to like the sine and cosine, I have to think backwards. So I know that if I took the derivative of cosine, I'm going to end up with a negative sine result. But because I don't have a negative sine result there, right, I'm going to go ahead and my result can't have a negative. So I'm going to have that extra negative up front to negate that negative when I'm doing the derivative. So it'll be negative 1/4 cosine of 4x. Don't forget the plus c. So the answer for 116 is C. All right. Oh, last page. All right. Ooh, this is gonna be ugly. So anyways, this I'm smelling a u substitution here. Because I know if I took the derivative of something with an x squared, I'll end up with like a linear function. I don't know. I'm going to try it. So u is equal to, and it usually is going to be this one with the higher power. So negative x squared plus x, du is equal to negative 2x plus 1 dx. I always want to get dx by itself. So dx is equal to du over negative 2x plus 1. And now I'm going to set up my integral and my substitution. So I still have this negative 4x plus 2 times now u cubed times du over negative 2x plus 1. So something's not canceling out beautifully here. Unless I factored out a 2 here. You got to do some manipulation here. If I factored out a 2 out of that, just a positive 2, then I'll be... spit on my iPad again. Just a positive 2, I'll be left with a negative 2x plus 1. And guess what? That beautifully cancels out all of my x terms, right? And now this 2 I'll bring outside of the integral, so that'll be 2 integral of u cubed and then du. So then this becomes u to the 4th over 4 times the 2, which reduces down with a 2 on the bottom. And then u to the 4th becomes now negative x squared plus x to the 4th, all divided by 2, which is the same thing as this one, right? It's because the 1/2 you can bring up front. Okay. Number 118. Yeah, this is another style where they tell you what the u is and you kind of have to play around with it. Okay, so if u is equal to all of that, I'll know I'll have the integral of the square root of u, because if u is x minus 1 and that's x minus 1, I'll substitute them, all divided by, and let's see, because even if I did like the whole du, like u is equal to x minus 1 and du will be equal to dx, then this will just turn into, or times du, right? But then I'm not really canceling out that x, right? So luckily, this is where you kind of look back at your u that you define and say, is that simple enough to where I can just move things around and get x by itself? And it turns out you can. I can go ahead and move the plus, the 1 to the other side and add it there. So it'll be u plus 1 is equal to x. And now I can just substitute this in for x. So u plus 1. So that pretty much eliminates those two. And now the only difference between these two are the bounds. And I mean, hopefully by now you understand that, if you're doing a u substitution, you're most likely going to change your bounds. So your new bounds, right? If we're going from x equals 2, then my u is going to be, it's kind of, hold on, this is confusing when I have that one there now. Yeah, so then my u is going to be x minus 1, so it'll be, my new u will be 1, and for x equals 5, my new u will be 4. So A. is the answer for 118. All right, so 119. Does this factor? Well, no, there's no... Oh! Nope. Erase. Yeah, I said it before. I'm not used to the long division problems because I don't remember practicing it that much when I took calculus. But I remember saying that if the power on the top is higher than the one on the bottom, you will always resort to long division. So let's do it. So I have x squared minus x minus 24. I have to do these really slow because I'm not the best at long division. So let's see how I do. So I know that my first term has to be multiplied to this and match up with the first term there. So that just looks like it's going to be x. So then x times x is x squared. X times negative 5 is negative 5x. And now I remember I have to subtract this whole thing. So x squared minus x squared is 0. And that's what's always supposed to happen. And then negative x squared minus negative 5x is going to change that to a positive. So it'll be positive 4x. Dude, I keep spitting on my iPad. Sorry. It's unprofessional. But anyways. So, okay, now the next term here has to multiply to this first term to equal 4x. So I'm going to do plus 4. I don't know why I changed colors, but so then 4 times x is 4x. 4 times negative 5 is negative 20. And so, oh, I was supposed to bring down my negative 24. Sorry, minus 24. So then now I know I'm going to subtract this whole thing, which pretty much means that I'm going to change the signs of everything on the inside. So then I have a third color now. So then these cancel out, and then negative 24 plus 20 is minus 4. And then, I'm pretty much done there because I can't really, so I can't multiply anything else here with x to get negative 4. So now what I'm going to do is I'm just going to rewrite this as the integral of x plus 4. And then with my remainder, I'm going to divide that by what I was dividing it. So it'll be minus 4 over x minus 5 dx. So then this integral becomes x squared over 2 plus 4x minus, and then, you can do u substitution, but remember when I told you that what you're going to do is you can just, if it's a linear function, right, you can just divide it by 1 over u prime, right, whatever your antiderivative is, like if this was u. And 1 over u prime in this case is just 1. So it'll just be the natural log of the absolute value of x minus 5, right? But because we have that extra 4 there, I'm going to put that 4 up front and then plus c. Please be an answer choice. 1/2 x squared plus 4x. Looks like it's b. Okay. Sorry, I had to read that carefully. They all look the same. All right. Now for this one. Oh, I'm already looking at the answer choices. I'm going to do some kind of completing the square here. Yeah, and that's the other thing. If I don't know how to describe it. If it just kind of looks like it's in that form, it's going to be completing the square. And I'll be completely honest with you. I don't even remember antiderivative of like the trig functions. I need to sit down and like actually memorize all of these. So anyways, okay, so how are we going to do this? So we're going to complete the square. So I have 1 over x squared minus 2x. And I know that I'm going to do the middle term divided by 2 squared. So plus 1 minus 1 plus 5, right? So I know that this turns into parentheses x minus 1 squared, because it's always the middle term divided by 2 is what goes in there. And then this becomes plus 4. Okay, so I think I can work with that. So I'm going to have the integral from 1 over x minus 1 squared plus 4 dx. And I know this is definitely going to be the tangent one, because the tangent one had some kind of u squared plus a squared, if I remember correctly. So I know that u was equal to the one with the x term, so x minus 1, right? And then a is equal to Well, I know u squared was equal to that. A squared was equal to 4. So that means that u is equal to x minus 1 and a is equal to 2. And I remember it had, and if we did all that substitution perfectly, right, because that means du is equal to dx. So if I did all of my substitution, that was an ugly fancy bracket. There we go. So if I did all of my substitutions perfectly, it'd be 1 over u squared plus a squared du. And that's a perfect substitution there. So this becomes inverse tangent of u over a plus c. But I think tangent was the one that had the 1 over a in front. I think. I don't remember. Oh my god. I'm going to go with it. Yes, tangent had 1 over a. Sine was the only one that didn't, right? I don't remember. Shoot. I need to again, it's when it comes to the memorizing stuff, I don't remember it. So it's 1 over 2, I believe, arctangent of, yeah, it has to be this one. It's either C or D. I don't remember if it has the 1 over. I think it does. So I'm going to go with C, and if I'm wrong, let me know and I'll tell the whole class. I should probably check that after recording this. Whatever. Sorry about that little bit of confusion. Hopefully that wasn't too distracting. I'll let you guys go. Goodbye. Love you guys. I got to go shower and get to work and be there on time. Sorry. Bye.